Hi friends, in this video we will solve two sets. It is a problem from introductory section of CSES problem set. In this problem we are given all the values from 1 to n and we are asked if it is possible to partition these numbers into sets so that their sum is equal. So that's the question. Let's move to the solution part. We are given all the numbers 1, 2, 3 up to n and we are asked if we can partition these numbers into sets so that their sum is equal. So what is the first criteria? Sum of these numbers equals to n into n plus 1 divided by 2. If this is equal to odd, then we cannot partition. So the answer would be no. If it is even, then we can partition it. Our answer would be yes. And we will see that in every case when the sum is even, we can partition it. So let's start from a very basic example. Let's say we have four consecutive numbers x1, x2, x3, x4. Now these are consecutive, that means x, x plus 1, x plus 2, x plus 3. Now if we want to partition these numbers into sets so that their sum is equal, what we can do? We can select these two numbers and these two numbers. So the sets would be x, x plus 3, x plus 1, x plus 2. So the sum would be 2x plus 3 and this sum would be 2x plus 3. So the sum is equal. Now we are all the numbers from 1, 2, 3 up to n. We can take the help of this thing. From the last, what we can do? We can pair every 4, means we can make a set of every 4 digits or every 4 numbers, and in all the 4 numbers we can select any two of the digits, either these two or these two, first and the last of that 4 numbers. And in the means in the left side, either we will be left with these 3 elements or 1, 2, 3, 4. So let's see these two cases on the next slide. This is the first case and this is the second case. Let's say n is equal to 8. That means 1, 2, 3, 4, 5, 6, 7 and 8. Now we are making subarrays of size 4. So these are the subarrays of size 4. From this subarray, let's take a standard approach and we will always select the first and the last element of each subarray. So the first and last element of this subarray and first and the last element of this subarray. Okay. So in this case, this was the second case where in the left side the subarray of size 4 is present. Let's take the example of n is equal to 7. Here 1, 2, 3, 4, 5, 6 and 7. When we are taking 4 elements from right side, then we are left with only 3 elements. So in the case of odd, just add a padding of 0. So we can select the same way, 3 plus 0 and 1 plus 2 all are equal. So the approach up to this point is same, and if n is odd, we can just add a 0 here, and the approach for this part would also be same. So we have found out that whatever value of n is, we can make two cases: if n is odd and if n is equal to n is even. When n is even, just start a loop I is equal to n, I greater than 0, I minus equals to 4, and just see out n comma n minus 3, or I let me replace this line with I comma I minus 3. So if n is 8, so we can write it here 8 and this would be 3, this would be 5. The next time 8 minus 4, that would be 4, and we will be taking 4 and this would be 1. So that is the answer for this case. That's the answer for this case. Now for when n is odd, so the same way that we were doing here, we will include just one more condition for I is equal to n, I greater than 0, I minus equals to 4. Now if I equals to 3, so in this case we will directly select the element 3, else cout I comma I minus 3. This is the only difference. We have included this condition only, this one more condition, nothing else is different. So that's enough for this video. Let's meet in the next video on bit strings. Thank you guys.